Okay, so we have to solve this question. Yesterday the homework for the question was x to the power 4 minus, sorry, x to the 4 plus x cube minus 7x square minus x plus 6. We have to find the, we have to factorize this equation. Okay, and we have discussed that an x power n plus an minus 1 x power n minus 1 plus dot 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 a naught, and if x minus p by q is the factor of this equation, then q divides an and p divides a0. Now if an is equal to 1, this means q is equal to 1, and that means p is an integer. P is an integer. What does this say? That if, not necessary, but if an is equal to 1 and if the roots are rational, then the roots have to be integer. Okay, if an is equal to 1 and, sorry, not 0, 1. If an is equal to 1 and if roots are rational, that means then the roots have to be integer. Have to be integer. Okay, so it gives us a hint,
Yes, sir.
that the roots may be integer. And okay, this p is the divisor of 6 and p is the root, so p has to be the divisor of 6 or the factor of 6. What are the factors of 6? Either plus minus 1, plus minus 2,
2 plus minus 2
plus minus 3,
plus minus 3
plus minus 6.
plus minus 6.
Okay, so what does this tells me? This tells me that if this equation has any integer roots, any rational roots, then the rational roots will be integer. And if this equation has any integer roots, then the roots can be only plus minus 1, plus minus 2, plus minus 3, and plus minus 6, nothing else. If there are other roots,
Okay.
then those roots has to be irrational or complex. So let's put x is equal to 1. And what is p of 1? P of 1 is 1 plus 1 minus 7 minus 1 plus 6. This comes out to be 0.
Yes, sir.
That means x minus 1 is the factor of this. Let's try and see.
Okay.
X is equal to 2. So let's put okay, minus 1. So p of minus 1 is equal to 1 minus 1 minus 7 plus 1 plus 6.
0.
This is also 0.
Hmm.
So x plus 1 is also the factor of this.
Yes, sir.
Let's put x equal to 2. And what is p of 2 equal to?
16, 8, 28, 2 plus 6. Yes, sir. It's also 0.
This is 0.
Hmm.
So x minus 2 is also the factor of this. Let's put x equal to minus 2.
Plus 2
This is not equal to 0.
No.
So x is equal to minus 2 is not the factor. Let's put x equal to 3.
-27 minus 60. No. Oh. Oh, sir, it's not 0.
No, right? Is this?
Sir, that's 0. Yes, sir, it's 0. So it's x plus 3. Hmm.
Okay. So what you are able, now we are able to factorize this equation. We know that this is the equation of the highest power 4.
Hmm.
That means it will have 4 roots. And we are able
Yes.
to find out 4 roots.
So, sir, in the rational zero theorem, we have to like substitute the factors of the numeral and then find the root.
That exercise you have to do. This is not saying anything with guarantee. It's only saying if a is equal to 1
Hmm.
and if this equation has a rational roots, then I'll say the roots will be the factor of the last constant term. So instead of doing hit and try, uh, suppose if this number was not 6, suppose this number was 5, then I can only say the rational will be plus minus 5, 1, plus minus 5. So you don't have to try with plus minus 2, plus minus 3, plus minus 4. The only way to solve the polynomial equation is for the quadratic equation. We know all the ways of solving it. But for
Yes, sir.
higher degree equations, you don't have any method to solve it. You always find the root.
Hmm.
And this eliminates all those other numbers. You understand the power of this theorem now?
Yes, sir.
I'll explain it. Suppose this is a polynomial and plus, let's say, 9. The factors of 9 are plus minus 1, plus minus
3 and plus minus 1.
9. So if an is 1, here the power is n. So an is 1. So if you want to try what are the roots of this equation, you should only try with plus minus 1, plus minus 3 and plus minus 9. We should not try with plus minus 2, plus minus 4, plus minus 5. Okay? Already eliminate all these numbers that they cannot be the root of this equation. So this helps us to find out if the integral solutions are there, then what integers can be the root of this equation, then we verify it.
Yes, sir.
Is this clear?
Yes, sir. Yes.
Okay. Now come to the next topic. If I say p of x is a polynomial, similarly like an x per n plus an minus 1 x per n minus 1 a naught, that is a polynomial of degree n. Then suppose we are able to break this into few linear factors and then few quadratic factors. These are linear factors and these are quadratic factors.
Hmm.
Okay. So that what does this mean is, I said yesterday that a polynomial can always be factorized into x minus alpha 1, x minus alpha 2, x minus alpha 3, x minus alpha n into linear factors. But then we are not guaranteed that this alpha 1, alpha 2, alpha n are real numbers. They can be complex numbers. They can be complex numbers. But if I have real numbers alpha 1, alpha 2, alpha 3, alpha k, where k is less than n, okay? And if I have numbers beta 1, beta 2, beta 3, beta j, some numbers, real numbers, and some real numbers gamma 1, gamma 2, gamma 3, gamma j. I'll tell you why I'm taking these numbers. Then this polynomial can be written in the factors like a multiplied by x minus alpha 1, x minus alpha 2 dot 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 x minus alpha k. What does this mean? We have k real roots. The rest of the roots are not real. The rest of the roots are imaginary, which we cannot find right now. We don't know how to write it. So then we write it as x minus beta 1 whole square plus gamma 1 square. X minus beta 2 whole square plus gamma 2 whole square. Dot 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 x minus beta j whole square plus gamma j whole square. Now remember, these are all linear factors and these are all quadratic factors. And these quadratic equations, they will give us complex roots. They will give us complex roots. We don't know right now how to find it. Okay, so that's why I'm saying it. That we can write this in, we can break this into some linear factors and some quadratic factors. Okay, and stop here only. We'll not go further in discussing this theory. You just remember this portion. Once we'll do some portion of the quadratic equation and some portion of the complex numbers, we'll again come and see if we can solve few questions based on this theory. Okay.
Yes, sir.
So last part of the polynomial, which will help us to solve good questions, is the relationship between the roots. Alpha 1, alpha 2, alpha 3, alpha n are the roots of the equation. Okay. The roots can be real, the roots can be imaginary or complex. I am not worried about it.
Yes, sir.
Then we simply say that the sum of the roots alpha 1 plus alpha 2 plus alpha 3 dot 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 alpha n is equal to minus sign a n minus 1 divided by a n. Okay. Then I will say the sum of the product of two roots taken at a time, that is alpha 1 alpha 2 plus alpha 1 alpha 3 plus alpha 1 alpha 4 dot 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 alpha 2 alpha 3 plus alpha 2 alpha 4 dot 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 alpha n minus 1 alpha n. This is equal to a n minus 2 divided by a n. Then if we take three roots at a time, alpha 1 alpha 2 alpha 3 plus alpha 1 alpha 2 alpha 4 dot 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 alpha 1 alpha 3 alpha 4 dot 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 alpha n minus 2 alpha n minus 1 alpha n, then this is minus of a n minus 1 divided by a n. If we do like this, lastly we come with the product of the roots alpha 1 alpha 2 alpha 3 alpha n, which is equal to minus 1 to the power n a0 by an. Okay, this is
Sir, but how do we get these results?
okay. So we are not going into the proof of this,
Oh, okay.
but I will give you a verification of this.
Okay.
X square minus 5x plus 6 is equal to 0. You remember this equation? This is my favorite equation because this I can easily factorize it. X square minus 3x minus 2x plus 6 is equal to 0, and this gives me x minus 3, x minus 2 is equal to 0. What are the two roots of this equation?
3 and 2.
So I say alpha 1 is equal to 2, alpha 2 is equal to 3. There are two roots. What is the
Huh.
sum of the roots? Alpha 1 plus alpha 2? 5,
5.
which if I see here is
Oh.
minus of minus 5 by 1. Minus of an minus 1 upon an. What is alpha 1, alpha 2? Which is equal to 6. 3 into 2.
6.
Alpha 1 into alpha 2 is minus 1 to the power n, a0 upon an. So this is minus 1 whole square, a0 is 6 by 1. This is equal to 6.
Yes, sir.
So I've just done I've not given you any proof. I'm just verifying that this result holds. Okay. And this is what I've done. I've written this is in a very expanded form. And this is very cumbersome. I don't prefer to write it, neither any books write it. So I'll give you the way how to write it. Whenever here cyclic symmetric expression, what is cyclic symmetric expression? When I am writing two or more variables, like if I write x plus y plus z, and if I replace x by y by z, and z by x, if I replace x with y with z, and z with x in a cyclic manner, this expression will not change. Then this is a cyclic way,
Yes, sir.
symmetric expression. If I write it as x square plus y square plus z square plus xy plus yz plus zx. So again, this is a cyclic expression. If you replace x by y by z, and z with x, then it remain unchanged. Or if you write it as x cube plus y cube plus z cube plus x square y plus z plus y square z plus x plus z square y plus x. Again, you see, if you replace x by y by z, and z by x, nothing will change. It will remain as it is. Is that clear?
Yes, sir.
So if we have these cyclic expressions, then use this sign. This is a sign sigma coming from the Greek alphabet, and this sigma sign is used for summation or sum.
Okay.
So this x plus y plus z can be written as summation of x. That means I have to repeat it. X plus y plus z, whatever are the terms. So the roots I can write it as summation of alpha I, where alpha I varies from 1 to n. So you have to value substitute value of I as 1, 2, 3, 4, 5, 6, 7, 8, 9 up till n. So you can write this summation sign stands for addition, sum. So I can write this as alpha 1 plus alpha 2 plus alpha 3 plus alpha 4. Just a second. Hello. Okay, I can write summation of alpha I alpha j where j is less than 1 I. That means this is equal to what? Sorry, I is less than j. Then I can write it as alpha 1 alpha 2 plus alpha 1 alpha 3 and all the combinations of I and j till alpha n minus 1 alpha n. And last I can write it as whatever. Last is just the product. So alpha 1 alpha 2 alpha n. Okay. I can write it as phi of alpha I. I is equal to 1 to n. This means alpha 1 multiplied by alpha 2 multiplied by alpha 3 multiplied by alpha n. Is this clear?
Yes, so the sigma is basically used to write in a shorter form.
Pardon?
So sigma is basically used to write that like in a shorter form.
Yes, yes, yes. You know, that gives us a very compact expression, right? It's very
Hmm.
difficult to write such a lengthy expression.
Yes,
This
sir.
is very short. So I can simply say, I will again repeat this. I can again say that summation of alpha I is equal to 1 to n is simply equal to minus of an minus 1 upon an summation of alpha alpha j is equal to minus, sorry, plus an minus 2 upon an and product or simply alpha 1 alpha 2 alpha n is equal to minus 1 to the power n a0 by an. You can write it as summation of alpha I alpha j alpha k, where again uh, this is equal to minus 1 an minus 1 divided by n. Okay, so this helps you to write in a very compact form.
Okay.
Is this clear?
Yes, sir.
So suppose if you know summation of alpha I and you know summation of alpha I alpha j, then if I ask you what is alpha 1 square plus alpha 2 square plus alpha n square, I'll give you one proof, rest you can do yourself. We know that alpha 1 plus alpha 2 plus alpha n square, a plus b square is a square plus b square plus twice ab. A plus b plus c square is a square plus b square plus c square plus twice ab plus twice bc plus twice c, right? So alpha 1
Yes,
plus
sir.
alpha 2 plus dot 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 alpha n square will be equal to alpha 1 square plus alpha 2 square plus alpha 3 square dot 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 alpha n square plus twice of alpha 1 alpha 2 plus twice of alpha 1 alpha 3 plus twice of alpha 1 alpha 4 dot 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 twice of alpha 2 alpha 3 plus twice of alpha 2 alpha 4 dot 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 plus twice of alpha 3 alpha 4 plus twice of alpha 3 alpha 5 dot 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 like this, which can be simply written as summation of alpha I square plus twice summation of alpha I alpha j. Now we already know this is what? This is summation of alpha I whole square. You know what is summation of alpha I? You know what is summation of alpha I alpha j? So we can write summation of alpha I square is equal to summation of alpha whole square minus twice summation of alpha I alpha j. So this is what? minus an minus 1 divided by an whole square minus twice of an minus 2 divided by an.
So can you explain the alpha summation of alpha I squared part which you've just written again?
This
Yes, sir.
this is given here. No, summation of alpha is this.
Oh, acha, okay, got it. Hmm.
So this gives me an minus 1 square divided by an square minus twice of an minus 2 divided by an. So this gives us an minus 1 square minus twice of an minus 2 multiplied by an divided by an square. Okay. So with these results, we are able to find out this result.
Hmm.
Okay. Is this clear?
Yes, sir. So 1 second, I'll just write it down. Yes, sir.
Okay. So I will over the class here only. What
Hmm.
you have to do is, if I see your this PDF file,
Hmm.
I have this question. X to the power 5 plus 3x power 4 minus 404411 x cube minus 12132 x square minus 1213263x minus 2011 square is equal to 0.
Hmm.
And the question says all the roots are integers. That is alpha 1, alpha 2, alpha 3, alpha 4, alpha 5. All are integers.
Hmm.
Okay. So you have to find out what are the distinct values of alpha 1, alpha 2, alpha 3, alpha 4, alpha 5. This question is from your book. Okay. The PDF you send me, the last
Yes,
question
sir.
of that book.
Okay.
Now this is a homework for you. What you have to think about it is the coefficient an is 1 here.
Hmm.
That means if the roots are integer, then the roots will be divisor of this.
Yes, sir.
So find out the divisors of this. Then another thing is you can apply that the sum of the roots will be minus 3 by 1. And you are done. First of all, you know the product of the roots will be coming from this number. The sum of the roots will be this number. And also you know that the roots will be only the divisor of this number. So what is 2011?
Yes, sir.
2011 is, I think, a prime number, right?
Yes, sir. Yes, sir. It's a
Three
prime.
factors of 2011 will be 1, 2011, and 2011 square. Nothing else.
Hmm.
That's all. So you know, and we also know that the sum, so the roots can be either plus minus 1, plus minus this, or plus minus this. But we also know the sum of the roots is minus 3.
Hmm.
The sum of the roots is minus 3. If you can combine all these things, you can easily find the answer. Is this clear?
Yes, sir. Sir, how do we get the sum of the roots again
How will
as
you get
minus
it?
3? The sum of the roots is minus 3.
From this formula? The sum of the root is minus n minus 1
Oh,
upon.
okay. So I should just remember all of these forms.
See, first of all, whatever theory I've taught you, you have to memorize the theory.
Hmm.
If you memorize it, you will not don't know how to apply it. Once you memorize it, and once I will apply it, you will remember, okay, I am applying that part of the theory. The first thing what you have to do is you have to memorize all the theory which I've taught you. And after that we can
Okay.
talk further. Okay.
Okay, sir.
So I will over the class here only today because I want you to memorize my 2 sheets which I given you yesterday. And
Okay, sir.
do this homework.
Okay, sir. So this question.
And pardon?
This question I should do as homework.
Just this question, and if I have question, I will give you homework again. I will
Okay.
contact you. But you have to send me the doubts today, whatever doubts you have in your sheet, so that I can all
Yes, sir.
solve before I come to the class. Okay?
Yes, sir. Yes, sir.